H plus ions or hydrogen ions, and bases are the substances which give hydroxide ions. The next topic is very important. In every exams, we are going to expect questions from the topic. So for today, we are doing the pH of a solution. So what do we mean pH of the solution? When we say pH, it is the short form of the word potence. Potence means power. Okay. So pH is denoted like this, small letter p, then H. So P means potence or power. Potence, or we can say power, and H means hydrogen ions. You can say potence or power of hydrogen ions. So that means pH, it measures the strength of a substance. So strength of an acid. pH, it measures the strength of acids. So the strength of acid is represented by their hydrogen ions. If an acid produces more number of hydrogen ions per liter of the solution, so that acid will be considered as a strong acid. If an acid produces less number of the H plus ions, so it will be considered as a weak acid. For example, if you have, generally we know that the concentration of the solutions, here I'll also talk of the concentration of solution. So the concentration of the solution will be measuring the concentration of solution in molarity. We call it will be written by this capital M, which we call as the molarity of the solution. So the molarity of the solution, it measures the concentration of the solution. That means how much part of the solution is acid and how much part of the solution is water. That is represented by the concentration of solution. Okay. If you have a 1 molar solution, so 1 molar solution indicates if you have 1 mole of acid in 1 liter of solution. If you have 1 liter of the solution, so in that 1 liter of the solution, in 1 liter of the solution, you have 1 mole of the acid. This is the meaning of 1 molar. This is what we mean when we say a 1 molar solution. If you say 2 molar solution, it means 2 moles of the acid are present in 1 liter of the solution. So if I have 2 molar concentration, it means 2 moles of acid are present. 2 mole acid is present in 1 liter of the solution. So again, I have 1 liter of the solution, and in that 1 liter of solution, here in that 1 liter of the solution, I have 2 mole of the acid. Okay. So the concentration, as you know, on the basis of the concentration, we call the solution to be either a dilute solution or a concentrated solution. So which solution will be more concentrated, a 1 molar solution or a 2 molar solution?
2 molar, sir.
Which one will be more concentrated, 1 molar or 2 molar?
2 molar solution.
2 mole
A 2
solution.
molar solution is more concentrated. It has more parts of acid in 1 liter of the solution, right? And out of these two, if I say this is solution A and this is solution B, so which solution is a dilute solution?
A.
Yeah, A is dilute and B is concentrated. Got it? So this was about the concentration. The next topic is about the strength of an acid. Strength means how strong the acid is. See, how the strength means, suppose I am taking 1 molar solution. Okay, I am taking 1 molar solution, and so 1 molar solution mean there will be 1 mole of acid in 1 liter of the solution. So let us say I'm taking 1 molar ethanoic acid, which is CH3COOH. I'm also taking 1 molar hydrochloric acid. So if I have 1 molar acetic acid, CH3COOH, I have 1 molar HCl. So as we know, if I mix this with water, when it is mixed in water, you get so this acetic acid CH3COOH will give us acetate ion and H plus ions. Yes, yes or no? Okay. So if I have 1 mole of HCl, so now HCl will also dissociate to give H plus ion and Cl minus. So here acid HCl, it dissociate to give us H plus and Cl minus ion. The acetic acid CH3COOH also gave us acetate ion and H plus ion. So HCl will give us H plus and Cl minus. Is this correct? Everyone has understood this, that both the substances, acetic acid and hydrochloric acid, both are having 1 mole of their acid in 1 liter of the solution. And acetic acid is giving you acetate ion and H plus ion. And H plus HCl is also giving you H plus and Cl minus ion. So out of these two ions, do you think that all this acid will dissociate? All the molecules of the acid will give you H plus ions? Yes, will all the acids?
Sir, maybe, but not sure.
Okay. See, suppose if you have 100 molecules of this acetic acid. I'm considering here 100 molecules of acetic acid and 100 molecules of HCl. Both of them, there are 100 molecules. Now, out of these 100 molecules, all the molecules of acetic acid will not dissociate to give this ions. In the same way, all the 100 molecules of HCl will not dissociate to give H plus and Cl minus. Out of this, okay. So out of this 100, suppose if you have you have 80 molecules of out of this 180 molecules are dissociating to give acetate ion and H plus ion. But for HCl, the number may be 98. Out of 100, maybe 98 molecules are dissociating to give H plus ion and Cl minus ion. So which one will you consider to be a better acid?
98.
98, yes. Since it is providing me more number of the H plus ions. The amount of the H plus ions determines the strength of the acid. So in 1 liter of the solution, HCl will be a strong acid. It will be giving me more H plus ions even if I have the same concentrations. Got it? Now this is measured with the help of the pH or potence. Since the concentration of the hydrogen ions, it can be along numbers. Generally, the concentrations of H plus ions, they are measured with the 10 to the power something, 10 to the power negative 14 or 10 to the power negative 7. This is how the concentrations of H plus ions are measured. So to have a better number, we find out the pH of the solution, and pH of the solution is defined as negative logarithm it is defined as negative logarithm.
Sir, I was writing sir previous part.
Okay, just 1 minute. Hydrogen ion concentration. So what you have to understand, that is the previous page only. This page you have to understand completely that what is pH. When I find the pH of a solution, I am finding the potential or power of the solution, power of the hydrogen ion.
Sir,
Okay. So
sir,
yes,
once can you explain more concept again?
Completed, sir. Thank you, sir.
okay. You want to understand mole concept, right?
Yes, sir.
See, mole concept is not in your syllabus. It was also not in a part of ninth, and here also we are not utilizing it much. Okay, just you can understand if you take 1 mole of a substance. Okay, suppose if you say 1 mole of HCl, it means you have 6.022 multiply 10 to the power 23 molecules of HCl. This is what does it mean, right? If you have 1 mole of acetic acid, so 1 mole of CH3COOH would mean 6.022 multiply 10 to the power 23 molecules of acetic acid. Got it? If I have 1 mole of water, so 1 mole of water means again same thing, 6.022 multiply 10 to the power 23 molecules of water. So is this much clear about the mole concept?
Yes, sir.
Yeah, only this much is required. The rest, if required, it's not required in your grade 10. The rest you will be doing in your grade 11. Okay. So when we find out pH of the solution, so if someone asks you what is pH, so you will reply from here. pH is the potence of hydrogen ions. It measures the strength of an acid. Okay. In a more better way, you can say pH is defined as the negative logarithm of hydrogen ion concentration. So this is for higher classes where we define pH as negative logarithm of hydrogen ion concentration. We can write pH equals to negative logarithm of H plus ion concentration. So here the square brackets, it represents the concentration, negative, and logarithm or log, it is a mathematical operation. Log or logarithm, it is a mathematical operation. Got it?
Yes, sir.
So this is how we define. Now the pH range of a solution. What can be the range of the pH? The pH range can be from 0 to 14. The pH range starts from 0 and it can continue up to 14. So pH of any solution cannot be less than 0 and it cannot be greater than 14. Okay. There is reason which you will understand in grade 11 that why the pH can't be less than 0 and why it can't be greater than 14. But as of now in your grade 10, you're supposed to know that the minimum value of the pH is 0 and maximum value of the pH is 14. Okay. So pH from 0 to 14. And on a scale, if I represent the pH like this, so the middle value is 7. Okay. For the pH, the middle value is 7. So the pH 7, if I have pH 7, so pH 7 represents a neutral substance. A substance which is neutral will have a pH of 7. Okay. So what should be the pH of water? What should be pH of water?
Sir, between 6 and 8.
It has to be 7. Since water is neutral, so it has to be 7. Got it? pH of water or pure water has to be 7. Since water is neutral, it does not produce any ion. Now, the solutions whose pH is between 0 and 7, they are acids. And the substances whose pH is between 7 to 14, they are the bases. Okay. So from 7, as you move towards 0, your acidic nature increases. Okay. You become more acidic as you move towards 0. And from 7, as you move towards 14, the solution becomes more basic and less acidic. So if I have here 3 solutions, let's say I have solution a solution B, and solution C. So that solution A has a pH of 3, B has a pH of 6, C has a pH of 12. So out of the 3 solutions, which solution is more acidic?
A.
Hmm. A is more acidic, and which one is basic?
C.
C. C is more basic. So can you so can you arrange them in the order, increasing order of the hydrogen ion concentration? Yes. Okay, see. So if I arrange them in the order, increasing order of their hydrogen ion concentration, so which one will have the least number of hydrogen ion concentration?
Maybe C.
Yeah, C has the least hydrogen ion concentration. So I put here C. I'm arranging them in the increasing order of hydrogen ion concentration, H plus concentration. So C has the minimum, then Then which one should have? Then after C, it's B. After B, it's A. A has the highest concentration of the H plus ions. Got it? Okay. Can you, if I talk in the same way, what about the hydroxide ion concentration? Which solution will have the highest hydrogen ion concentration?
A.
Okay. A will have the highest hydrogen ion concentration. No, hydroxide ion.
C.
Hydroxide. C will have the highest hydrogen concentration. So you are given A, pH 3, B having pH 6, and C having the pH 12. So in the concentration of H plus, we have C has the minimum concentration, then we have B, and then we have A. In OH minus or hydroxide ion concentration, so the solution C will have the maximum number of hydrogen ion concentration. So for the hydroxide, the minimum concentration will be for A, then for B, and then for C. So C has the maximum hydroxide ion concentration. Okay. So with the pH, see, this is how your pH scale looks like. With this diagram, we are able to see how does pH determine the nature of the solution. So increasing nature of acids. So when we have pH as 0, so all we have is H plus ions. As we increase the pH up to 7, so the concentration of the H plus ions decreases, and at pH 7, the concentration of H plus ions and OH or hydroxide ions, it's the same. The concentration of H plus ions and the hydroxide ion, it remains the same. That means at 7, the substance is neutral. pH 7 means the substance is neutral. Okay. If we have pH greater than 7, so pH greater than 7 means the concentration of the H plus ions is decreasing and concentration of OH minus ions is increasing. Okay. So here at 14, you have the minimum H plus ions and maximum OH minus ions or hydroxide ions. So everyone has understood the pH?
Yes, sir.
Yes.
Anyone having
Yes,
problem with
sir.
pH? Okay. So now pH is found out or pH is determined by using a pH paper. We generally use here a pH paper to find out the pH of the solution. So pH paper. When you dip a pH paper in a solution, the color of the pH paper changes, and whatever color is obtained, depending on that color, we predict the pH of the solution. So a high pH will give you red color. If a solution has a high pH, it will give you red color, and if a solution has a pH nearly 14, it will give you blue color. In between, at pH 7, you will obtain green color of the soil. Green color will be obtained for the pH paper. See, I'll also show you how does a pH paper look like and what are the color changes that are observed. See, this is how we obtain the different colors that can be obtained on a pH paper. So on a pH paper, if you take a pH paper and dip it inside a solution, you change the solution changes the color of the pH paper. If the color of the pH paper is red, so the pH is going to be 0 or 1. And if it's green, so pH is like to be neutral. And if it's blue, dark blue, you are going to get a high pH of 13 or 14. So these colors, they are a rough guide. Okay, with this, you can't get the actual pH value. To get the actual pH value, you must use some other indicators. Okay, with the pH paper, you are just having an idea what is the pH of the soil. Okay, so see here, you can see the lemon juice, which has a pH of nearly 2, gastric juice, which has nearly a pH of 1.2, then pure water or blood will have a pH of 7 or 7.4. Milk of magnesia, which is magnesium hydroxide, has a pH of nearly 10. pH of 14 is for sodium hydroxide, which is a strong base. So for a strong base, the pH is 14. Got these pH values?
Yes,
Okay.
sir.
Just like acids, we know that acids are corrosive in nature. So in the same way, bases are also corrosive in nature. Acids and bases both are corrosive in nature. Let me add the indicator over here. This is a rough indicator diagram. So both acids and bases are corrosive. Both acids and bases are corrosive in nature. So they corrode the surface. If they are poured on a surface, so they corrode the surface. Got it? Let's see some questions which may be following this pH. Now, importance of pH in everyday life. Why pH is important for us in everyday life? Okay. So, since the strength of acid is important, we want to measure if I have a strong acid, so how strong the acid is. So, the strength of the acid, it will determine the different properties of the substance. So, here we have pH in everyday life. So, we will be talking here pH of soil. What should be the pH of soil? We'll talk here of pH in body. In the human body, we'll talk of pH of blood. We'll have pH of blood. We'll also talk of pH of gastric juice. So gastric juice is the juice which is secreted by the gastric glands in the stomach, and it contains hydrochloric acid, pepsin, and mucus. So these three substances, they are contained in the gastric juices. So we'll talk of the pH of the gastric juice. We'll also talk of pH as the cause of tooth decay. We'll also talk of certain other things as pH. So pH of solution soil. A soil should be generally neutral in nature. It should not be highly acidic or it should not be highly basic in nature. Since plants obtain their nutrients from the soil, So pH of the soil should be maintained neutral, or it should be nearly neutral. Okay. If sometimes due to acid rain or due to some other factors, the pH of the soil changes. If the pH of the soil change, so lime can be added in the soil. So if you have an acidic soil, if the soil is acidic, so then you add over there lime in it to neutralize. So it will make it again neutral. So as we know, lime is calcium hydroxide. If you make a sorry, calcium oxide, if you make a solution of calcium oxide, that is you get calcium hydroxide. So calcium hydroxide is a base. If you add calcium hydroxide to the solution, the soil will turn out to be basic in nature. Okay. It will neutralize the acidic content present in the solution, and hence the soil will be again useful for the plant. If we talk of pH inside our body, so blood is almost neutral. It has a pH of 7.4. So blood has a pH of 7.4, which is roughly neutral. And pH of the gastric juice is nearly 2. It lies between 2 to 3. Or no, so it lies between 1 to 2. The pH of the gastric juice is between 1 to 2. So it is strongly strongly acidic inside the stomach. And that is why you have learned that in this strongly acidic condition, the hydrochloric acid performs the function of killing of the bacteria or killing of the germs inside the stomach. Okay. Then about the tooth decay. So our teeth is made up of calcium phosphate. Got it? Which is when we are talking of the tooth decay, we are mainly discussing about the enamel part. The enamel of the teeth, it is mainly made up of calcium phosphate, and enamel is the hardest in the in our human body. We have the bones. So this enamel, it's calcium phosphate, and as you know, this is a salt of a metal, which is calcium. So when we eat food, and after that, if you have say some food particles get stick to the food. So if you have some food which gets stuck in your teeth, so this food is acted upon by the bacteria present in our mouth. So we have certain bacteria present in our mouth which turn this food into an acid. So whatever food gets stuck in the teeth, it turns into an acid with the help of the bacteria present in our mouth. Now, acid can react with calcium phosphate. So this acid, whatever acid is formed in our teeth, this acid reacts with calcium phosphate, and it causes the so some parts of the calcium phosphate, they react with this acid, liberating the surfaces. So it will cause the corrosion of the surface. This will corrode the surface. Yes, corrode the teeth surface. Yes or no?
Yes, sir.
Yes. So acid will react with calcium phosphate, just like we had seen that acids react with carbonates and hydrogen carbons. In the similar way, acids also react with phosphate. So here you have a phosphate calcium enamel. Acid reacts with the calcium phosphate and it corrodes the surface. The surface gets corroded. So some parts of the calcium phosphate react and they leave the surface. So it leads to creation of the cavity. When some part of the calcium phosphate they react, so you have a creation of the cavity. Cavities are created in the mouth. Okay. What are cavities?
Holes.
Yes, holes. Yes, small holes or small pores are created in our tooth. Okay. Now, if small pores are created or small holes are created, they will lead to increase in the amount of food that will stick to your teeth. So, slowly and slowly, more amount of food will stick to the teeth. More amount of food sticks to the teeth, and hence what will happen? It will increase the amount of acid content, and hence more and more corrosion will occur. So slowly and slowly, you will have all the enamel of the teeth being eaten up by this acid. So this is what happens. If you look up, I think you must have studied about the structure of the teeth, where you have the tooth enamel. And so this is the upper portion or the crown of the tooth, which you will observe. This is the enamel. So slowly and slowly, some potholes are created here. Okay. So these, due to the cavity, this cavity is created, more and more food will get stick over here and acid will be created. Now, when a large amount of cavity is created, so these acids they are able to reach the nerves. When the acid reaches the nerves, then it causes pain, and that is the time we become aware that yes, we have got a tooth cavity. We have a tooth cavity here. Understood? So the reason behind tooth cavity is the pH of the teeth. We must maintain the pH of the teeth to be neutral. Okay. So can anyone tell me if I'm using a toothpaste? So what should be the pH of the toothpaste? Should it be acidic or basic?
Sir, basic, sir.
Basic.
Yeah. So
Basic.
a toothpaste should be basic in nature to neutralize the acidic content. And so can you think of why do we advise neem to use neem for instead of toothpaste? Why do we advise use of neem?
Your toothpaste has chemicals, no, sir. And neem is natural.
Yeah, neem is natural. It contains a lot of bases are present in neem. So that is why it's bitter in taste. So when you use neem, it neutralizes all the acid content of the teeth. Okay. So all the toothpastes they have to be basic in nature. Got it?
Yes, sir.
Yes, sir.
Yes or no? So
Yes,
today
sir.
we have done pH in everyday life, where we have seen the pH of the solution. We have seen pH is necessary in our body and pH as the cause of the tooth decay. Okay. So I think everyone has understood. Bye everyone. Good
Sir, could
night
you show
and
the
see you
previous
all
page,
again.
sir?
Yeah.
Sir, please show the previous page, sir.
Previous page. Yeah.
No, sir, before one, sir.
Okay. Yeah.
Thank you, sir.
Okay. Okay. Bye all. Bye all of you. See you again tomorrow.